So this is a pretty short video just dealing with the next type of polymerization reaction, and that's known as condensation polymerization. Absolutely nothing new here for you, but we'll just quickly talk about what makes a good monomer for this type of reaction. So a good monomer, two reactive termini, and so by that I mean the ends of the molecules are reactive and can participate in condensation reactions. So primary diols, that is OH groups on either end of a molecule, dicarboxylic acids, or diamines, all are good starting points for this type of polymerization. I'll just quickly show you what I mean by that. So here you have a diol. So that OH group will be able to react with this dicarboxylic acid. And so that OH group and the OH group of the dicarboxylic acid react. So we get off water, condensation reaction, and we form that ester bond between the alcohol and the carboxylic acid. But the thing is, I still have this reactive OH group and this reactive OH group on the ends of this new molecule that's been formed. And so this molecule comprised of a diol and a dicarboxylic acid will continue to be reactive, will continue to bond with other ends of similar molecules. So the chain can continue to be built. Similar with the diamines. So if you remember, this is where I'm going to get a reaction with an amine and a carboxylic acid, and there I get my amide linkage, which we also refer to as a peptide bond. So I get my amide linkage, and so I now have a dicarboxylic acid bonded to a diamine, and I still have the reactive termini at the end. So on this end of the amine I have that NH2 group which can react, and back here on my dicarboxylic acid I still have that OH group that can react. And so those are why these types of molecules are very useful as starting points for condensation polymerization. So let's look at a couple of examples. The first one is a polyamide, and you've probably heard of this Kevlar. So Kevlar is a very useful material, and it comes about by condensation polymerization between terephthalic acid, which we would commonly refer to as 1,4-benzene dioic acid, and phenylene diamine, or 1,4-diaminobenzene. And so here's where we're going to form that bond, that amide linkage. And so the molecule we get looks like this. So C double bond O, bond OH, benzene ring, C double bond O is still there, bond N, that has an H, benzene ring, with my NH2 terminus. And so a couple of things about this molecule. So this is Kevlar. When this polymerizes, this is Kevlar. Reactive hydroxyl group on one end, reactive amino group on the other end. But the interesting thing about Kevlar, part of the thing about Kevlar is its mass to strength ratio is strength to mass ratio is about the highest known for a lot of products, and part of the reason is right here. So between the chains, that's an N bonded to a hydrogen. So that's going to link via a hydrogen bond with another strand of Kevlar. So that's what gives it its great strength. Also very heat resistant, so it's a very useful material. Is Kevlar, and so made up of terephthalic acid and phenylene diamine. So an example of a polyester is PET, which is made up of, again, of terephthalic acid and ethylene glycol. And PET stands for polyethylene terephthalate. and so it gets put together via a bond forming right here, and so we know that as an ester bond. And when we get our ester bond, the molecule then that results, again we have our C double bond O, bond OH, benzene ring of the terephthalic acid, C double bond O, and now I have my ester bond, and then I have a couple of carbons, and I still have my reactive OH group. And so there's my molecule that's going to polymerize. Again, it's going to polymerize because I still have a hydroxyl group and I still have a hydroxyl group. So the ends are still reactive. And so that's a polyester, and there's lots of polyesters around. You may have heard of a couple of them. There's a couple very common ones. Dacron is the registered trademark name. And Dacron is very commonly used as a fiber. It's used in rugs, it's used in clothing, very common. And then another one is mylar, which you also may have heard of. And mylar can be formed into very thin sheets, and so it's a common component of plastic film for bags, and also for the types of tape you see in magnetic tape strips and things like that. So those are a couple of examples of condensation polymerization. Now, in terms of finding the monomer, again, you still need to be able to do that, but it's really not that hard, because condensation polymerization, you're always looking for carboxyl groups. So there's the carboxyl group of interest, and there is my amide linkage. And so now I can see my two molecules. And so the two molecules I have, again, they're C double bond O, OH, and I'm going to shorten this to CH2. And so there's 1, 2, 3, 4, CH2, 4, and then it's bond C double bond O, OH. So that's 6 carbons, so that's 1,6-hexane dioic acid. And then here I have my amino group, so there's my NH2 at the terminus, and I'm going to shorten this down, and that's CH2, 6 NH2, and so that is also hexane 1,6-diamine. And so those two are the molecules that would make up this monomer. This monomer, by the way, is nylon, and specifically it's nylon 66, a specific type of nylon. And that concludes this video.